Hey guys, so what we're looking at today is 3.2, floating down the river. So let's go ahead and get started. All right, so solving linear systems by graphing. Graph each set of linear equations on the same set of axes. Name the coordinates of the point where the two lines intersect. So what we're going to be looking at here is graphing two lines on the same graph to see where they intersect, which is one way to take and solve a system of equations. So we're going to start with the f of x. It's going to be our blue one. So we have 2x minus 7. So we're going to start down at negative 7 because that's our y-intercept. So 1, 2, 3, 4, 5, 6, 7. So there, I need to make that bigger. And all right, so there is our y-intercept. Now we have a slope of 2, so that means we're going to go up 2 and to the right 1. Up 2 to the right 1. Up 1, 2, wait, 1, 2 to the right 1. Up 2 to the right 1. Up 2 to the right 1. And yes, you should do the line all the way across. It's going to make your life easier. So keep going up 2 to the right 1, up 2 to the right 1, and then come down here and go down 2 and to the left 1. So going down 2 and the left 1 is the same thing as going to the up 2 and to the right 1, because negative and negative makes positive, and positive and positive makes positive. So here is our first line. Now for our next one, I'm going to take, and our g of x is going to be in this purpley pink. So it's at positive 5. So we go up 1, 2, 3, 1, 2, 3, 4, 5. So there's our y-intercept, and then it's got a negative 4 slope. So that means we're going to go down 4 and over 1. We go down 1, 2, 3, 4, and over 1. Down 1, 2, 3, 4, and over 1. Come back up here and go up 1, 2, 3, 4, and over 1. All right, so there are two lines. Now, my advice to you is to draw these lines in, not just leave it a bunch of points. For me, that's going to make it a little more confusing because I can't draw it as straight as you guys would be able to on the computer here. But we can see where these intersected. It's at this point right here, because we have a blue point underneath this purpley pink point. So if we look, we're over at 1, 2. So we're at 2, negative 1, 2, 3. So the solution to, well, I wrote it down here. Your point of intersection should be right up here. Your intersection point and the solution to these two equations is 2, negative 3. So that's where they intersect, which is the solution to any system of equations. So the intersection point is always the solution. This is the one point that works for both equations. Now, when you have a fraction for a slope, you may be panicking because, oh my goodness, it's a fraction. Don't panic. It's not as bad as you think. So let's start with the f of x. We have 2/3 x plus 4, so we'll go up 4. 1, 2, 3, 4. And then we have a 2/3 slope. So we're going to go up 2 and over 3. So 1, 2, 3. Up 2 and over 1, 2, 3. So you don't even have to worry about trying to figure out what 2/3 is, like figure out 2/3 on the graph. It's just you're going up 2 and over 3 because our slopes always represent rise over run. So how much we're going up over how much we're going over. So then down 2 and over 1, 2, 3. Down 2 and over 1, 2, 3. Down 2 and over 1, 2, 3. Remember, we want to have that full line. It's going to make your lives so much easier, I promise. All right, now we do the g of x. So we have negative 1/3 x plus 1. So we've got our positive 1 for our y-intercept. And then we have a negative 1/3 slope. So that means we're going down 1 and over 1, 2, 3 to the right. Down 1 and over 1, 2, 3 to the right. Down 1 and over 1, 2, 3 to the right. Then here you're going to go up 1 and over 1, 2, 3. up 1 and over 1, 2, 3, up 1 and over 1, 2, 3. So we have our lines graphed out and we can see the intersection point. It's right here where these two are both at. So we're over at 1, 2, 3, -3, +2. So there's our intersection point. Now, on number 6, we have f of x equals x. All that means is your y-intercept is at 0 and you're going up 1 over 1 every single time. So that's what it looks like for 1/2 of it. So finish the line out this way. Anytime you have just, a negative x or just an x, it's a -1. So it just means you're going up 1 over 1 or down 1 over 1, depending on the situation, okay? All right, so make sure you finish up number 6 and then do 2, 3, and 4. All right. Describing attributes of a function based on graphical representation. For each graph, state the intervals where it's increasing, decreasing, or constant, and if it has a minimum or maximum, and identify the domain and range. Use interval notation. So if we look at, let's see, we're going to do number 9. So for number 9, if we look at where it's increasing, I need to shrink that down. Hang on. So increasing, that's going to be from, notice this continues off the page. We don't have an endpoint. So being as there's no endpoint, we're going to assume it goes on forever. So if it has a specific solid point, that means it's got an endpoint. Otherwise, you're going to assume it goes on forever. So that means it's going from -infinity, because we're going off and to the left, that's -infinity, all the way to -2. So when we say our increasing and decreasing, it's always going to be your x values, never your y values for increasing, decreasing, constant. So this is going from -infinity to -2. Now, it's constant. So constant means a flat line. There is no growth whatsoever from -2 to +5. So if we look, we're going perfectly straight. There's no growth until 5 when we start decreasing. So we have our decreasing, and it's going to be from -5 to +infinity. So there are our intervals for increasing, decreasing, and constant. Now, for the next part, we wanted the maximum or minimum. So this does not have a minimum, but it does have a maximum. Maximum at 2, because notice 2 is the highest y value. So the maximum is at 2 over -2 to 5. So because this is an interval, it's got a whole range where it has that maximum for. So for the maximum or minimum, then you are going to be looking at the y value. And then last but not least, domain and range. So domain is your possible x values, range is your possible y values. So domain, what's the furthest to the left that we're going? Well, if we look at our increasing, it's -infinity. And look at the end of decreasing, to infinity. So we've got -infinity to infinity. Pretty much that's the most common kind of domain to have, unless there's specific endpoints. That's going to be your most common. Won't always happen, but it's most common. Now our range, what is the lowest value we can go to? Well, we can go all the way to -infinity. What's the highest y value we can go to? Well, we don't ever go higher than 2. That's our maximum. So there is our maximum. So that's our range. So range is your y values. Domain is your x values. Okay? All right. And last but not least, write equations for the given tables in both recursive and explicit form. So if we look at number 12, we have 0, negative 13, 2, negative 5, 3, negative 1. What are we going up by between these? Now be careful, don't look from negative 13 to negative 5 because our n value, we're at 0 to 2. So that's not going to give you what our common differences. So looking between numbers that are right next to each other. Otherwise, you have to do slope, which is y2 minus y1 over x2 minus x1. This is something you need to know. You should know how to find slope. So taking two of your y values, subtracting them, and then taking their corresponding x values and subtracting them, dividing. Make sure you know this. So looking at this, we don't need slope because we have two numbers right next to each other. So how do we go from negative 5 to negative 1? We add 4. So we know we're going to have 4n, and this will be now equals previous plus 4. Now remember, on linear equations, we always have to have the 0 term. So this is going to be minus 13. If we didn't have the 0 term, we'd need to put it in the form of the 0. We'd have to find the 0 term or use the point slope form to write our equation. Okay? All right. The next one we're going to look at is here, number 11. So we have 1 and 6, 2 and 12, 3 and 24. What's happening each time? We are multiplying. So we're doubling it each time. So we can use any term. I'm going to use the first one, 6 times 2 to the power of n minus 1. Remember, your exponent is affected by which value you pick to use in your equation. And then your recursive is now equals previous times 2. There you go. So 10, 13, 14, that's what you're looking at for writing your explicit and recursive equations. No, we haven't gotten away from those yet. All right. Your keyword for this lesson is intersection. If you guys have any questions, feel free to ask. Have a great day, guys. Bye.